exercise 2 finally. All right. So suppose u and v are vector functions that possess limits at as t approaches a, and let c be a constant. So we're asked to prove these properties and basically just show that they're the same thing as for regular limits. So prove the following properties. So if you have the limit as t approaches a of this right here, this addition or subtraction, so u of t plus v of t vector functions, this just equals to the limit as t approaches a of the u t vector, u of the u vector function plus the limit of the as t approaches a of the v vector. So basically, if you add the vector functions and then take the limit, is the same as doing the limits of them separately and then adding them up. And then in part B is limit as t approaches a of, now we have the constant times the vector function, and with this one we can just take the constant out. And then part C is the dot product of the vector functions. The limit is the same as doing the limit of them individually and then taking the dot product, and same with the cross product for part D. The limit of the cross product is the same as the limit of each vector function multiplied by the a cross product with the other limit of the vector function. All right, so let's take a look at the solution. But before we get to each part, what I'm going to do here is basically I'm going to define the term. So I'm going to go let u, so u vector function, and then define each of these component parts. I'm going to go as u1 of t. So this one has component parts and it's in 3D. u2 of t, and then u3 of t, like that. That's the component parts of this one. And then likewise for v of t, this equals to v1 of t, v2 of t, and then v3 of t, like that, right? All right, and basically we define these, and then basically the next setup is, I'm gonna fix this up a bit, move this right here. Yeah, I'll just move this right here. All right, a bit higher. All right, so in each part of this problem, the basic procedure is to use definition 1. Basically, the limit of a vector function equals to the limit of its component parts, and then analyze the individual component functions using the limit properties we have already developed for real valued functions. So let's take a look at the solution to A. So A is this one right here, addition or subtraction. The same thing would follow, but we'll just do with the addition because this was part of the exercise. So we're gonna take this part right here, and I'm gonna go reverse. I'm gonna. Oops, I was erasing it. So what we'll do is take this and then reverse it to go backwards. All right, and doing the component parts and so on. So expand them out. So let's take that right here. So I'm going to go limit as t approaches a of u vector function plus limit as t approaches a of v vector function. This right here, this equals to, this equals to the limit as t approaches a of, now we do the component parts of every single one, and we should put this inside. I'll move this over. So this is the same thing as the limit of each one separately. This is just definition 1. This is going to be now, this is f of, u1 of t. And then limit as t approaches a of u2 of t. And then limit t approaches a of u3 of t. And this is going to be like that. And already here, I just quickly shrunk that in, and then that's the u one. Now we have to plus the v one. I'll try to write it a bit smaller. Limit as t approaches a of that's inside of it. So this is going to be limit t approaches a of v1 of t, and then limit. So again, it's just very tedious but straightforward. You just put using the definition definition 1, and put this all inside. And this is t approaches a of, this is v3. And we know the limits of these component functions must exist since the vector functions both possess limits as t approaches a, i.e. if the limits of the vector functions exist, then so does their component function. That's definition 1, where the limit of this, basically the limit of this one, again, that's definition 1. If these limits exist, the components have to exist. And also from again here. So we're told that, suppose u that possess limits as t approaches a, so they both exist, and then you add them up. So add them up would also exist and so on. But I mean the component parts have to exist because they exist. Anyways, then adding the two vectors and using the addition property of limits for real valued functions, we have, so what we get is, just put this down again, limit as t approaches a of u of t plus limit as t approaches a of v of t vector function. Okay. This is going to equal 2 now, and then we could sum all these up. This one here, we just sum up the component parts, so limit as t approaches a, and then this is going to be u1, and then plus this one right here. So again, these are just basic limit properties now, because these are real valued functions, so we can add these up. Limit, and this is just just the basic functions right here. Limit as t approaches a of u1 of t. Actually, no, yeah, these aren't real valued yet, but nonetheless, these are, actually, they are. This will equal a, because it's not a vector function anymore. This is just a real function, and then that equals a limit, so that we can just add up those limits, same thing as adding them up. And then this is going to be of each component, so the limit as t approaches a of, this is u of t2 of t, and then the next one. And I want to fit these all in one line, so what I'm going to do is, I'm going to write this down here. So that equals 2, and I'll move it all the way across here. Let's see if I could fit everything into one line, otherwise I'll have to shrink it. Is limit t approaches a of u2 of t plus limit, I'll make this a bit bigger, limit t approaches a of u, v, 2 of t, and finally, let's move this all the way here, limit as t approaches a of u3 of t plus limit as t approaches a of v3 of t. And then put a close bracket. Alright, here, and I quickly just shrunk this in to fit one line right here. Alright, so we shrunk that in. So now this equals 2, and I think what we could do next is, well, this limits right here, these are the limits of the same things. We just add these up, and this is a v2, not u2. So it's v2, v1, not the other one. That's u1 of t plus limit v1 of t. Yeah, so that's what it is, and then all these line up. And then what we could do is we could take the limit out and then sum these up separately. So we could take the limit like this, and this becomes a u1 of t, so separately like that, plus v1 of t, like that. And then next part is limit, and this is going to be u2 of t, plus v2 of t. So just, again, the both limits are the same, so we just basic limit properties, so just take that out. And then next one is limit t approaches a, and this is going to be u3 of t plus v, erase this. Alright, and add a plus v3 t, and close that up and see if it fits in. Yeah, it fits in our line. Actually, we need one more bracket. And then fits in our line like that. Let's see if it fits in. Yeah, it fits in. Close it out. We have some room. We'll make it neater. Alright, so that should be exactly there. Yeah, so we have that. And, alright, so we have this, but this is just definition 1 on the right side. So in other words, the limit of each component part, we could just go backwards and get back into the limit of these separately. So in other words, Yeah, I mean the limit of the vector functions added together. So then this just equals to, I'll put this right here. Yes, in other words, we could take these limit out, again, just going reverse from the definition. 1, this just equals to limit. We could take that whole limit out. Same thing. So limit of the component parts, same thing as limit of the total. And this is going to be now, this is going to be of the vector u1, u2, v2, like that. Oh, this is v1. I keep getting that mixed up. U2t plus v2 of t, and then u, and then like this, erase this, u3 of t plus v3 of t, like that. So that's what we have there. And again, I'll put this right here, write this down as, right, fix this t there. And this is, I'll just put this right here, using definition 1. 1 backwards. So that's how we got to it. That's how we got it. And again, this whole setup is, well, this is just the limit of this right here. And this is just a vector of the vector functions added together. U1 of the component parts added together. So then this just equals to limit as t approaches a of the vector functions added together. ut plus v of t, like that. Epic stuff there. So that is what we get. That is, we just proved it. So we just proved it, go back to A, and there is A right here. So we went from here all the way back to there. So now let's take a look at part B. And this one, now we have the constant right here, and then we could take it out. So we'll start off with, in this case, we'll start off with this one right here, and then go backwards to that one. All right. All right. So let's, jump right into solution B. So we'll do that. So we're going to write this as limit as t approaches a of c times by u of t, like that. Now this equals to, again by definition, 1, put these all in the component parts together, so this is going to be equal to, actually before we even get to the component parts, I'm just going to write this out as limit as t approaches a of, put these all in, just in the components, c1, we don't have to put the limits in right now, c1 u of u t, this is again by definition what this means, C U T, and then C U T3, U3 now, and then close this all like that, and yes, that's what we have. And we will put this all together into one. So that's equals like that. But we could take we just take the limit of each component part. So it's the same thing. This is going to be limit as. So just for completeness, put that all together. So now it's going to be like this. CU1 of t. And then limit as t approaches a. And this one's pretty straightforward. Alright. And this is going to be CU2 of t. And then limit t approaches a like that. CU3 of t. Like that. Alright, and then for completeness, let's write this all out. Now we just have a basic limit right here, a limit of a function, and then we can take the c out of the limit. Again, we already covered this before. This just equals to, again, for completeness, put them all together in there. This just equals to, right here. Yeah, so put them in each one. So take the c out, limit, and then t approaches a, and this is of u1 of t. Try to power through, and this is going to be c, limit, t approaches a, u2 of t, and then cu3. Oops, before we do that, limit, and this is going to be u3, like that. And again, now this is just a constant inside of a vector. The components, we take the c out. And now the c is going to be out of it like that. Limit t approaches a of u1 of t. Limit t approaches a of u2 of t, limit as t approaches a of u3 of t. Like that. So that's what we have. Alright. And then finally, we can go from here to reverse direction of the definition. 1, so this limit of a components, that's just the same thing as limit of the full vector function. Or we take that out first. So this is equals to c times it by limit as t approaches a of, right here, this is going to be u1 of t, u2 of t, u3 of t. Alright. So that's what we have. And in other words, this right here is just a vector, the u vector function. So this is going to be limit t approaches a of the u vector function, like that. And I'll just box this in like that. Right, and that is exactly what we have. Yeah, so that's what we have, and we can see that from the value right here. So there's the b. So limit as so we went from here, and we got all the way over to here. So we took the constant out, just using basic limit laws and definition of the vector function limit. All right, and now let's take a look at part C. And this one says limit as t approaches a of right here u of t dot product with v. And that equals to the limit of each vector function dot product with each other separately. So we take the limit and then take the dot product. It's equal to the same thing as taking the dot product and then taking the limit. All right. So what we'll do here is we'll start off from here in this solution, and then we'll reverse like that. Again, that's a solutions manual had it, but again, pretty straightforward stuff there. So let's go to solution to C. So what we'll write is the limit as t approaches a of u of t dot product with v limit as t approaches a of v of t. This equals 2, and this equals 2, and I'll put it down here because we're gonna need a lot of space. So this is gonna be equal to, and now we take this and put the limits inside of each component part. So in other words, the same thing as writing limit as t approaches a of its component parts u1 of t, limit t approaches a of u2 of t, then limit t approaches a of u3 of t, then dot product with, so we need to dot product with it all, or it is pretty extensive. So what I'll keep doing it here, and I'll just shrink it. It's going to be dot product with limit as t approaches a of u. This is v now. v1 of t. This is going to be now limit t of a like that. Yeah, t approaches a of v2 of t. Finally, we have limit as t approaches a of v3 of t. Like that. Like this. Alright, so now we have that, and now we can take the dot product, and dot product as well, you just multiply each component and then add them up. So multiply this by this, add up with this one times by this one. So in other words, we get something like this. Yeah, here I just shrunk it up to put it in here, so we're going to get a limit as t approaches a, times it by u1 of t, and then times it by, this is going to be a multiplication, so put it like that. This will be a limit t approaches a of u1. This is v1 now. So we multiply this one with this. With this one, this and this, multiply it by each other, and then the other one, and so on. So we just do that each one, and then add them up. This is just a dot product, if you recall from my earlier video. So this is, you should have it ingrained in your head by now, if you followed me this far. This is going to be limit as t approaches a of u2 of t, and then this is going to be limit, let's fix that up, limit as t approaches a of v2 of t, and then plus last one, so one more, is limit as t approaches a of u3 of t multiplied by, fix this bracket, limit as t approaches a of v3 of t. Alright, so we have this. Yeah, we have this now, and now we can simplify, do some simplifications. This is, we have this limit right here, and then times it by this one. Well, that's just the multiplication. We could take the limit out of these separately. So this equals to limit as t approaches a of, now, this one could be separate. This is just u1 of t times by v1 of t. Alright, and then this again, basic limit laws. Now we can take the limit out of the this one in the middle, because they're the same limits as t approaches a. So we could do that as well. This is going to be u2 of t, and then v, and then v2 of t, and then plus limit t approaches a, and now it's going to be a u3 of t, v3 of t, like that. Alright, fix this t up. Alright, and then what ends up happening here is, well, this is a straightforward, take another one. This is another limit law of addition. We just take all the limits out. So limit as t approaches a, and now what we end up having is a big giant u1 of t, v1 of t, plus u2 of t, v2 of t, plus limit as this goes to, yeah, I mean, there's no, we already took the limit out, u3 of t, v3 of t, like that. In other words, this right here, this just equals to, yeah, this just equals to the limit as t approaches a, and it's just a dot product of the, yeah, this is just a dot product of each one separately. Yeah, this is just u vector function dot product. Yeah, you take a dot product of these two vectors, vector functions, and then take the limit. So same thing. Yeah. So this is correct, and we can yeah, go look at it above here. So there is the limit right here. So we went from here and showed that, yeah, the limit of each vector function and then dot product is the same as taking the dot product first and then a limit. All right, now let's take a look at part D, and this one is now we do the same thing for the cross product. So the limit of the cross product, you do the cross product then take the limit, is the same as doing the limit of each vector function u and v and then taking the dot product. And yeah, and in this one also we're gonna go from in this part D, we're gonna go from here and then go backwards and show it again using just a basic definition and limit laws and so on. All right, so let's jump right into part D for the cross product. All right, so let's take a look at the solution part D. I'm gonna write down now we have the limit, so we're gonna take it from the right side first. So basically write it like this: limit as u vector function of t, cross product with the limit of t approaches a, and now this is v vector function like this. And a good way to memorize the cross product is again using the the method where you just draw it in the determinate form or in the matrix form. So what we'll do is this same thing as writing limit. I like writing it like this, and this is going to be u 1 of t, and this is going to be our I vector, like that, and this is going to be like this, and then the next one is, this is the bottom one is the v vector, v1 vector of t, and then this is going to be our j, and this is going to be limit t approaches a of u of 2 of t, and this is, and yeah, remove these vector signs. These are components of the vector function. So those are bytes. Those are just regular functions. And then this is going to be the bottom limit t approaches a of v2 of t, and then the k component right here. It's going to be the limit as t approaches a of u3 of t, and then this is going to be limit as t approaches a of v3 of t. I just put it like that just so it's easier to memorize how to do the cross product. Alright, so now we have this, now we could take our, do the cross product, and then if we recall how we do it, just cross this out, and basically cross this out, and then basically have this one multiplied by this, and subtracted by this multiplication. Alright, so I'll erase this. So let's see if we could, how many lines we could fit this in. Hopefully we can try to shrink it. So this is going to equal to, like this equals to, and this is going to be the, I'll put it in this bracket form. And instead of writing ijk, I'll just leave it like that. So it's going to be u limit as, and this is going to be multiplied like this, t a u2 multiplied by, this is going to be limit as t approaches a of v3, and then minus, this is going to be limit of u3 of t approaches a of u3 times it by, put this there so that we're not dot parting, we're just multiplying. This is going to be limit. This is going to be limit as t approaches a of this is, and also yeah, we can't dot product because it's not a vector. These are just functions right here. This is going to be v2. So this one. So this times by we're going to subtract this times this, and this is going to be v2 like that. And then we put a comma for the next setup. So that's comma, and now we do the next one. Is going to be like this. Yes, if we recall, we do it. So now we cross out this one right here, and then the bottom one's going to be a minus. So instead of having this multiplied by this, then subtract by the other one, we're gonna instead have, because it's be a minus. Let's do it because we don't have much space. I'll do it this way here. This one multiplied by this, and then subtract, because the middle one's the only one that has a negative one. So we do the opposite side. So what we'll do is, this is going to be limit, put in a bracket, limit as t approaches a of u3 times it by limit as t approaches a of v1, and then minus limit t approaches a of u1, and then limit times it by t approaches a of v3, like that, and then comma. All right, then comma, and then the last one, just do it the same as the first one. So we erase this, cross this out, so now we multiply these two together, subtracted by this one over there. All right, so let's erase these. All right, and also cross this out. All right, so we get the idea and cross this out. Okay, so this is going to equal 2, or this, the next part is going to be, and again, that's going to be u1 v2. So limit t approaches a of u1 of t, and then limit as t approaches a of v2 of t, and then the other one's the reverse direction, minus limit t approaches a of, now it's going to be the u2. So reverse direction, instead of u1, it goes u2, and then goes to limit, instead of v2, goes v1, and then this is going to be v1 of t, and close bracket. There it is. That's the closed triangle bracket there. Alright, so now we have this, and now the next setup is just again using basic limit laws for functions. So we can take the limit out of this multiplication, and also the subtraction. So we'll just do that all in one go. Yeah, so what we end up getting is this equals to limit. Actually, each one separately. So we're going to do a like this. This is going to be equal to, put it like this, limit as t approaches a of, now this is going to be u2 v3, u2 of t, v3 of t, and then subtracted by this one right here, u3 v2. u3, and again, you can see this, if this is u2, then, and that's v3, the next one's going to be u3, and then the other one's v2. So it's always just reverse. Alright. So that's this one here, and I'm going to move this over. Right here, just so it's all in one line. I mean, 2 lines, we don't need to go 1 line. This equals like this, and then put a comma, and the next one's going to be limit t approaches a of, now this is going to be, this middle one is going to be u3 v1 and then u1 v3. So u3 limit t approaches a. Actually, no, we already got, my bad, we already got rid of this limit right here. Alright, so we already got rid of that. So this is going to be just, yeah, that's just going to be right here, u3 v1 and then u1 v3. So u3, okay, u3 of t, v1 of t, minus, and then this is going to be u1 of t, v3 of t, like that. And then that last one is going to be, where's my eraser? There it is. And last one's going to be limit as t approaches a, and this is going to be, yeah, u1 v2. So u1 of t, v2 of t, and then the reverse direction, u2 of t, v1 of t, like that. And yeah, this is a close bracket for close this. And then this is close bracket. There it is. That's what we have there. And now what we have these are the limits of the components, and then we go reverse on the definition 1. In other words, this is the same thing as writing limit of the full vector of function, not just the components. So this equals to limit t approaches a of the full setup here. Yeah, and now this is just going to be u2 u2 of t, v3 of t minus u3 of t, v2 of t, and then comma, the next setup is going to be u3 t, v1 of t minus, and see if I can fit this all in. Yeah, so I will write this all in and then shrink it or shift it. And then this is going to be u1 of t, v2 of t minus u2 of t, v1 of t, and then close bracket like that. Alright, so here I just moved it in and shrunk it so it all fits one line. And that is, yeah, let's double check my solutions manual. Yeah, this is exactly, yeah, this is the cross product of, and then this just equals to, well, this whole thing just equals to the limit. This is a cross product. Limit as t approaches a of the cross product. ut of cross v. Alright, so there it is. And that's exactly what we have there. And yeah, we can just scroll back up to the question, and we could see, yeah, so basically we went from here, we showed that the limit of the individual vector functions, then the cross product equals the same thing as if you take the cross product and then take the limit. So yes, epic stuff there.